Example 8. One more time. We've got several logs in here. So let's group them over to one side. 2 times log base 4 of x minus log base 4 of x plus 5 equals -1. Okay, I have a number in front of this log, so before I even combine them together, let me just write that as an exponent instead. Might help us out later. Okay, I've got 2 logs separated with a minus sign, so when I bring them together to make them as 1 log base 4, because it's a minus sign, we're going to create a fraction. Okay, and then from there, since it's all combined together, all the logs are to combine together into 1, take it out of this form into exponential. So 4 to the -1 is equal to x squared over x plus 5. Now, at this point, I can multiply both sides by x plus 5 and clear the fraction, but I'm looking over here to the left and I realize 4 to the -1 is a fraction. It is actually 1/4. And sometimes the easiest way to solve when you have a fraction equal to fraction is cross multiplication. So let's multiply those two together and multiply those two, and then that's going to get rid of our fraction. So we'll have 4x squared is equal to 1 times x plus 5, which is x plus 5. Looky here, we've got ourselves a quadratic. So let's get all the terms onto one side. I'm going to choose to put everything on the left so that way my front term stays positive. And then we're going to go about factoring. So I think it's going to be a 4x and an x. Let's put the 5 right there. We'll make it negative. Put a +1 right there. Let's double check. 4 times 1 is 4x minus 5x will be a -x, and then -5, so we're good. This one will give, first parentheses will give me x is equal to positive 5/4. The second one will give me x equals -1. Going back into our original problem, looks like -1 and 5/4, they both check out in the second parentheses, but in the first one, when you're just x as is, looks like we can't use the -1. So our only answer is x equals 5/4. And when you get to your test, this is exactly what I'm looking for. Go ahead and go through all of these steps right here. Show me the 2 potential answers and just mark out the one that doesn't work, so that way I know exactly what you're doing. You're going back and checking your answers. That's awesome. Okay, so let's finish wrapping this up here. We want to write 2 to the 3 log base 2k without logs. Okay, what I want you to do to figure out what to start working on this problem is let's just look up here in this exponent. If I just gave you this and I said simplify it a little bit, what you might do is just take that 3 that's in the front and put it back as an exponent. So let's start there. So it really is saying log base 2 of k cubed. Now there's this property, if you go back to your list of all those properties that are in your notes right above the first example, is that if the base, this is like base, here's your exponent up here, okay? But the exponent itself also has to be log. Well, if the base for your exponent and the base for your log are the exact same thing, all you get as an answer is what you're taking the log of, which is k cubed. And that's all your answer is. Think of it as this, like that wipes away with the log part, and you just get k cubed. Okay? We want to do that same property, if we can, here on example 10. I see technically what's out front here is a -1, so I can write it as 8 to log base 2 of k to the -1. Okay, that takes care of that part. And then what we want to do is if I can get this base to be a 2, because this base is a 2, that will knock all that off. Well, 8 is 2 cubed. So 2 cubed now is being raised to that exponent. Okay. If you have a base that's raised and re-raised, remember we multiply these 2 exponents together. So 2 to the 3 log base 2 of k to the -1. Looks like I now have another number I want to bring it back up. So I'm just going to multiply it to the -1. And we're going to make that then k to the -3. Okay? So what I did is basically rewrote the base of 8 as 2 cubed. And the reason why I wanted to do that is because I wanted the base for the exponent part to equal the base of the log part. And now that they're both 2 and 2, it's going to take away that log part, and our answer is just k to the negative 3, or if you want to write it as 1 over k cubed, so you have positive exponents, that's completely fine. Alright, looking like we're probably coming up on our last two examples here. This first example is we want to write 2 to the log base 8 of k without logs. Okay, and always what we wanted to start out to do was to look at the two bases. I have 2 and I have 8, and I need them to be the same. Okay, we can always manipulate exponential, the base of an exponential form. So we can always manipulate this number. When in your log, if your base is 8 or your base is 5, you have to stick with it. There's no way you can ever change the base of a log. You can change the base of an exponent, you can never change the base of a log. So here's my question, is how do I get 2 to basically equal 8? Because that's what I want. I want to switch this to an 8, so that way I can cancel with the 8 from the log, and then all that goes away. Okay? Well, let's think about it. What can I do to an 8 to get it back to a 2? Well, let's think. If I take the cube root of 8, is that also the same thing as 2? Which it is. So that's kind of where we're headed with this. Okay? And remember, the cube root of 8 is actually the same thing as saying 8 to the 1/3 power is equal to 2. Okay? So let's come back over here. Here's our original problem. 2 to the log base 8 of k. Okay, so I can rewrite, instead of having a 2 right here, what I'm going to do is write it as 8 to the 1/3 power. All of that to log base 8 of k. Alright, so remember, 8 to the 1/3 is 2, because it's just the cube root of 8 is 2. I haven't changed the problem. All I did was just rewrite that base. That's all I've done. Okay, and I have now 8 is raised to the 1/3 and re-raised. So let's multiply those together. So it's 8 to the 1/3 log base 8 of k, and let's bring that front term back as an exponent. So it's going to be 8 to the log base 8 of k to the 1/3, and now 8 matches with 8, takes the log with it, and we just get k to the 1/3 as our answer. So that one was kind of a tricky one, but just to realize, let me just tell you, whatever your base is for your log, you can't manipulate that. But you can definitely manipulate anything else if you want to, especially when it comes to exponentials. Okay? Alright, we want to know that given log base a of x equals n, we're going to use property 8 from the first page to write log base a to the 4th of x and log base cube root of a to the x in terms of n. To get this problem started, what I first did is I went and decided to rewrite property 8 for you over here on the left. So if you look to the left side of the screen, property 8 says log base b of a is equal to log of a divided by log of b. And what this is called is the change of base formula. What it says is your old base used to be a b, and if you ever want to change it to anything else, you can use this form. So what you're taking the log of, in this case log of a, it goes in the top, and then what you divide by is the log of your old base, which is b. And what I did is I changed the base to 10, mainly because you don't see a number here, but if I wanted to, this is the same thing as if I could say log base 3 of a over log base 3 of b. It could be log base, it could be, in the first one it's 10, here it's 3, it could be -4. It's just anytime you want to change your base from what it was, which was a b, to something else, this is the formula that does it for you. Okay, so this is the first example when we have log base a to the 4th of x. Okay, so before we decide what base we want it to be, let me just split it up. So it's going to be log of x divided by log of a to the 4th. What we want to do is figure out what we want this new base to be. Do we want the new base to be 10? Do we want it to be 1? Do we want it to be -3? So what we're going to do is go back up into the original problem, and they give us some information. It tells us that log base a of x is n. Well, I have log of x. What this is telling me that if I choose that base to be an a, then I can replace all of that top, that numerator, with n. So there we go. So if I want to make the top have a base of a, then I've got to do the bottom also have a base of a. And log base a of x, it tells me that's n. And let's look at the denominator. Log base a of a to the fourth. The base of the log is the same thing as the base of the exponential part. Those cancel off, taking the log with it, and it just gives us 4. And there we go. That's all we have to do, because now everything is in terms of n. It's just n divided by 4. All right, so let's try this one more time. We have log base the cube root of a of x. Okay, so we have log of x divided by log of the cube root of a. And again, what do we want our new base to be? We get a pick. If we go back to the original problem says if I pick that base to be an a, then the numerator is going to cancel off and give me just n again. So we're going to do that. So log base a of x is n, but we're going to do some little more cleaning here. Remember, the cube root is the 1/3 power. So what this is, now that I rewrote, all I did was rewrite the cube root of a is 1/3. So the base for the log is the same thing as the base for the exponent. Those cancel each other out, taking the log with it. And this is saying n divided by 1/3, or if you multiply the top and the bottom by 3, kind of clean this up, or multiply by the reciprocal of the base, the answer is 3n. And that's what you have done, and that helps use you property 8. It's a really, really neat tool whenever what you started with, the base you started with, you don't like, and you just want to rework it and to get a new base that you can work with. This is the exact property to use.